Okay, in this video, we're going to be doing Calc AB problem set number 96. The problems in a playlist are in the description below. Let's do the problems. Number 1, evaluate. So we got the limit as n approaches infinity of the sum from k equals 1 to n, quantity 1 over 5 minus 2k over n, all squared, times 2 to the n. So this is almost certainly going to be a definite integral. That's how these show up. When you see a summation in Calc AB, you know that you're talking about a definite integral. You just have to figure out what the function is, what the bounds are, and then do the fundamental theorem on it. So I look at this thing and I think immediately, this thing hanging out here, 2 over n, that's going to be our delta x. So I'm going to jot that down. So delta x is 2 over n. Now I need to figure out what am I plugging in? So what's my x sub k? Well, if you look at it, there's something that feels like it should be x sub k, to me at least, the denominator of this thing. I see 5 minus 2k over n. It's got like a delta x in there, right? The 2 over n. Looks good to me. So I'm going to say that x sub k is 5 minus k times 2 over n. Once you have x sub k, you need to figure out what x sub 0 is and x sub n. So x sub 0, you literally plug in 0 for k and you just get 5 minus 0, so 5. X sub n, you plug in n for k and you get 5 minus 2. And 5 minus 2 is 3. So once we've got all this information, now you say to yourself, well, what am I actually plugging into? Well, you can replace x sub k, the 5 minus k, 2k over n, replace that with an x, right? And look at what you get. You get f of x is the quantity 1 over x squared. So I think our function is actually just 1 over x squared. So that's what I'm going to choose to use. So we can take our summation and rewrite the whole thing as this definite integral. 3 to 5, 1 over x squared dx. Then we can evaluate it. Often on the AP exam, they just ask you to choose which of the following integrals is equivalent. But in this case, we can actually find it. So I would rewrite this as 3 to 5 x to the negative second. Then it's plus 1 times the reciprocal. So we get negative x to the negative first. We're going from 3 to 5. So we're going to do negative quantity. Plug in 5, you get 1/5. Plug in 3, you get 1/3. And then you can, simplify this as far as you want. So 2 over 15, I think, is our answer. Let's take a look at the next question. We want to, so these are two of the common questions that you run into that are a little weird, but pretty straightforward when you actually know what you're doing. So limit as x approaches 5 from the left, absolute value of x minus 5 over x minus 5. Step 1, construct the graph of the absolute value of x minus 5 over x minus 5. But that's actually just 1 when you're to the right of 5 and -1 when you're to the left of 5. So we can graph this. Looks like that. Has open circles at both of those points. But in terms of limits, it actually doesn't matter if they're open or closed. So now we need to approach 5 from the left. So do that. And you can see that 5 from the left, you're definitely just on the line y equals -1. So that answer is -1. The next one, definite integral of an absolute value, especially if it's linear, you're just going to graph the absolute value function, but really you end up just graphing 3 key points. You need to know where you are at -3, that's where you're starting, at 1, which is the vertex, and at 6, which is where you're ending. So all I'm going to do is create a graph that contains 1, -3, and 6. Now we're going to plug in, right? So plug -3 in, you get -4, absolute value of -4 is +4. Plug in 1 and you definitely get 0. Plug in 6 and you get the absolute value of 5, which is 5. And this is what we get. Add up the area of these triangles. That's how you should always tackle that problem. People always get a little intimidated. That's a triangle that has a base of 4 and a height of 4, so 16, but then half of that. And then another triangle that has a base of 5, a height of 5, so 25, but half of that. Don't be afraid of this. Just know what to do, right? So you don't have to find an antiderivative of the absolute value thing. All you really need to do is look at the graph. Don't forget, you can think of definite integrals geometrically. You can think of them algebraically. You have a lot of options. All right. Given that g of 7 is equal to 8 and g prime equals f of x, use the table of values for the function f to approximate g of -3 using a right Riemann sum. So this is kind of an interesting question. My first thought is, I need to find g of -3. I know g of 7, and I also know g prime is f of x. So I can fundamental theorem this thing, right? G of 7 minus g of -3 should be the integral from -3 to 7 of g prime of x dx. Now the key is like G prime is f of x, so I can like do the problem. If I just had what I currently wrote, you can't really do the problem. But now I can rewrite this as g of 7 minus g of negative 3 is the integral from negative 3 to 7 of f of x dx, because g prime is f of x. So what we'll do is a right Riemann sum on the integral negative 3 to 7 f of x dx. So that's where we're going. So this is an approximation because we're just doing a Riemann. All your Riemann sums are going to be approximations. So approximately, all right, from negative 3 to 1 is 4. And then it's a right sum, so we use 5 as the height. From 1 to 3 is 2, right Riemann sum, so we use 1 as the height. And then from 3 to 7 is 4, and it's a right Riemann sum, so we use 4. That's 20 plus 16 plus 2, which I think is 38. All right, so now what does this mean? Well, this is what we're trying to evaluate, right? So we know g of 7 is 8. We're looking for g of negative 3, and we just approximated that integral with 38. Now it's like an algebra 1 problem. I'm going to subtract 8, and then I will divide by a negative. So I think that g of negative 3 is approximately negative 30. It's kind of an interesting problem. I don't remember writing a problem like that before, but it combines a bunch of ideas. Not really bad. That's the end of the problem set. I hope this was helpful, and good luck.